Welcome to the deep dive. Today we are taking a massive foundational leap into the architecture of modern cloud security.
We really are.
We're tackling what is probably the trickiest yet most crucial area of cloud administration, identity and access management in Azure.
Yep, I am.
And this deep dive is a little unique. We're not just, running through the documentation. We've organized our discussion around a stack of high-stakes scenario-based problems.
The exact kind of conceptual traps Microsoft uses to test your reasoning for the AZ-104 Azure Administrator Certification exam.
Exactly.
That's right. If you are aiming for that certification, identity and access, the IAM component is where the conceptual gaps can really lead to failure.
For sure.
So we are focusing on clearing up the ambiguities, the subtle distinctions between components that, they seem to do the same thing, but they operate completely differently in Azure.
Right.
Our mission here is to give you the precise mental framework you need to identify and avoid common assumptions around Azure RBAC Microsoft Entra ID.
Which we all still call Azure AD by accident.
We all do. And managed identities and service principles, we're turning complex theory into, actionable, unforgettable knowledge.
I love that because this isn't just about getting certified. Getting this piece of architecture wrong in the real world means security breaches, administrative chaos, and those late-night phone calls nobody wants. Our discussion today is built around understanding the why one identity type is preferred over another and why scoping a role matters more than the role itself. Okay, let's unpack this with the first and most foundational question, which is arguably the biggest conceptual hurdle in Azure.
It has to be.
The crucial distinction between the identity layer and the resource layer.
The separation is the true north of Azure architecture. Everything else builds on this. We have two separate access control systems that operate independently.
And the confusion between them is?
It's the immediate source of administrative errors.
Let's look at scenario 1 to test this conceptual divide. We have a requirement. A user needs to manage other people's accounts. Specifically, they must be able to reset passwords for other users in the organization.
Okay, a common help desk task.
A common task, but with a critical security constraint. This person must have zero access to any actual Azure resources, meaning they cannot deploy, delete, or even view virtual machines or storage accounts. They just manage the people.
This is the perfect test because it forces you to immediately distinguish between the identity plane and the resource plane. The action resetting a password is focused entirely on the user object itself.
And this is where the mental trap kicks in, especially for administrators coming from other environments. We see the word administrator, and our instinct is to look for a powerful, overarching Azure role. What is the common wrong assumption here?
The default wrong choice is often to look at Azure RBAC roles, perhaps the owner role or maybe the slightly more nuanced user access administrator. People assume that because they are administering something within the Azure ecosystem, they need an RBAC role to do it.
But tell us why that fails dramatically. If I assign user access administrator at the subscription level, why can't my admin reset passwords?
Because the user access administrator RBAC role has one job and one job only: managing access to Azure resources. It gives you the power to assign RBAC roles to subscriptions, resource groups, or individual VMs.
So it governs the resource management layer.
Exactly. It has zero power, zero API calls, and zero visibility into the identity layer Microsoft Entra ID. It cannot touch users, groups, MFA status, or passwords. If you try to use that role for a password reset, the Entra ID service rejects the call instantly.
That distinction is so elegant in its security, but so frustrating in its complexity. We have to internalize that if the action involves the object, the user, the group, the authentication method, or the password, that operation is owned entirely by Entra ID.
Precisely. If it's an action on the identity fabric, something related to managing users, groups, authentication, MFA, or passwords, the permission required is always an Entra role. This takes us entirely outside of the Azure Resource Manager, or ARM, hierarchy.
So, based on the scenario, the user only manages identities. The correct solution is to assign the user administrator Entra role. This role is native to Entra ID, giving full control over user properties and resets.
And critically, because it's only an Entra role, it grants no inherent RBAC access to the subscription. Security requirement satisfied.
And that's the conceptual elegance you need for the exam. The roles are perfectly segregated. Now, as the exam often does, let's throw in the complexity challenge. What if, 6 months later, this same admin needs to manage both the users and assign RBAC roles to a specific set of resource groups?
Right.
In that case, we don't look for one magical role that does both
It
because
doesn't exist.
it doesn't exist.
Yeah.
We respect the separation of concerns and combine the two distinct permission sets.
Exactly. You would assign user administrator, Entra, so they can continue managing identities, and you would also assign user access administrator, RBAC, scoped appropriately so they can manage access to resources.
This reinforces the principle of least privilege by keeping the identity permissions separate from the resource permissions. They operate in different control planes.
They absolutely do.
So the biggest exam takeaway from this section: if the scenario involves managing users, groups, authentication, MFA, or passwords, you must look for an UNTRA role. Things like user administrator, password administrator, or global administrator.
And if it involves configuring, deploying, or deleting an Azure resource, VM, storage, you name it, the answer is an RBAC role. That is the fundamental architectural line you must never cross.
Okay, now that our users are authenticated via Entra ID, let's move entirely into the resource management layer, Azure RBAC. This is where we control what they can touch.
And the decisions here, role choice and scope, they dictate your entire security posture.
The core mantra here must be the principle of least privilege. We are moving from the broad Entra plane to the highly specific resource plane. Let's start with the classic dichotomy, contributor versus owner.
The big one.
Scenario 2, developer access. A developer needs full control of their application's Stack App services, storage accounts, and Key Vault, but strictly within a single designated resource group for their specific project.
Okay. So the initial impulse that we must suppress is assigning owner at the subscription level. That is the fastest way to fail the security objectives.
Why? What's the danger?
Because the blast radius is enormous. If the developer's identity or workstation is compromised, an attacker gains the keys to the entire subscription.
The whole thing.
The whole thing, including the ability to delete production resources and, crucially, elevate the access of other compromised accounts.
So the correct solution minimizes both the privilege and the scope. We assign contributor at the resource group scope. Why is contributor the gold standard for daily operations, and how exactly does it differ from owner?
Contributor is a standard builder role. It allows a developer to create, configure, modify, and delete virtually any resource. They can deploy a VM, set up networking, and configure the database, everything needed for a modern application.
Okay, so it sounds powerful.
It is. But the key differentiator, which is the most tested point on the exam, is that contributor does not include the permission Microsoft.authorization role assignments right.
That specific permission, the role assignments right, is the critical difference, right?
It is the difference between management and governance. Role assignments right is the permission that lets you modify RBAC itself. It lets you assign roles to others. Owner has it, contributor does not. By assigning contributor, we give them maximum resource functionality while completely preventing them from escalating their own privileges or granting access to unauthorized parties. And the RG scope limits the impact to just that application stack.
That makes perfect sense. Contributor allows resource modification. Owner allows resource modification and permission modification. So if the exam asks you to grant maximum control over resources without allowing security changes, contributor is the definitive answer.
Absolutely. Let's reinforce this with scenario 7, preventing privilege escalation. We have a new junior admin who needs to manage resources, running maintenance, scaling out VMs, but we must ensure they never gain the ability to assign roles to others.
If we have internalized the previous point, the answer is immediately clear, but let's talk through the trap. The wrong assumption here is that we need to find some kind of restrictive custom role or a deny assignment to take that power away.
That's over-engineering. Because contributor simply does not possess the power to assign roles, assigning contributor is the correct, safest, built-in solution. The only two built-in roles that can assign roles are owner and the specialized user access administrator.
So if the junior admin has contributor, they can manage the VMs, storage, and networking. But the security perimeter remains secure because they cannot invite unauthorized users in or grant themselves a higher role. Now, let's introduce a common security curveball. What if the junior admin needs to assign access to storage containers? Specifically, they need to grant a data scientist the ability to read the documents inside the container. Does contributor give them that power?
Absolutely not. And this circles back to our plane division, but with a twist. The RBAC contributor role is strictly for the management plane.
Right, it controls the storage account settings.
Exactly. Assigning a data plane role, like storage blob data reader, requires its own specific permissions, and contributor does not grant those data plane permission assignment rights either. The separation holds up. Contributor allows resource management, but not permission management on either the resource plane or the data plane.
Moving up the administrative hierarchy, we hit scale. When you start managing dozens or hundreds of subscriptions, individual assignments become impossible. Scenario 9 tackles multi-subscription consistency. A cloud architect needs the exact same contributor access across 4 different development subscriptions.
Okay, so the initial manual-minded approach assigning contributor 4 separate times is administratively inefficient, impossible to audit consistently, and prone to drift. That's the wrong approach.
The correct architectural solution relies on the hierarchy above the subscription, the management group. We assign the contributor role once at the management group that contains all 4 subscriptions.
Management groups are the crucial layer for enterprise governance. They are organizational containers that sit above subscriptions. When you assign a role at the MG level, that permission efficiently and consistently inherits downward to every single subscription, resource group, and resource beneath it.
It just centralizes control.
Exactly. If you add a 5th subscription next month, the architect automatically gets the right access without any intervention. This is how sophisticated enterprises manage scale for the exam. If a question involves multi-subscription access, organizational consistency, or scale, the answer almost always involves the higher scope of a management group.
Let's flip this around to a diagnostic challenge. Scenario 14, diagnosing unexpected permissions. A user complains they can modify a database, even though you distinctly remember assigning them only the restrictive reader role at the database's resource group scope.
This tests the concept that RBAC is fundamentally additive, and this is where people who are used to firewalls, where the most restrictive rule wins, get confused.
Okay, let's address that confusion head on. If I assign reader at the lowest scope, shouldn't that be the most restrictive and therefore win, overriding a higher permission?
It absolutely should not, and that's the key difference between allow assignments, which is RBAC, and deny assignments, which we'll discuss soon. RBAC is built on the principle that the user's total effective permission set is the sum of every single allowance they receive.
The sum.
The sum. Whether that comes from their user account directly, any group they belong to, or any scope RG subscription MG above the resource.
So the correct explanation is that the user must have a higher scope role, like contributor at the subscription or management group level, overriding the local reader restriction.
Exactly. The lower scope restriction, like reader, is irrelevant if a higher scope allowance, like contributor, is present. All permissions are summed up. And since the exam often focuses on the troubleshooting steps, the correct diagnostic action here is to check effective access in the Azure portal for that user on that specific resource.
Checking effective access is your single source of truth. It consolidates every assignment the user has inherited from every level of the hierarchy and tells you the final, accumulated set of permissions they possess, cutting through all the confusion about group membership and scope inheritance.
It's the ultimate diagnostic tool for RBAC.
We've mastered the core concepts of scope and contributor versus owner. Now we move to the edges of RBAC, how we manage specific data access, operational limits, and how we implement absolute denial.
These are the scenarios that test your knowledge of fine-tuning the access controls, moving from full control to just this one action.
Let's revisit the critical divide between the planes with Scenario 8. Accessing only storage data. A security analyst needs to read logs, which are blobs, in a storage container to perform analysis, but they must be explicitly forbidden from modifying the underlying storage account configuration.
Right, and the trap is assuming reader is enough. We covered this briefly, but let's dive into the technical details. Reader is a management plane role. When you use the reader role, you are talking to the Azure Resource Unker API, the ARM API.
So you're asking ARM things like,
where is this storage account located? What tags does it have? What is its replication setting?
The filing cabinet analogy is perfect here. Reader lets you view the label on the outside of the drawer.
A great way to put it. But to access the content inside the data plane, the actual blobs, files, or queues, you must talk directly to the storage service endpoint. That communication requires a separate token and a separate authorization layer, which is handled by the data plane roles.
So if the analyst needs to read the logs, the correct, secure, least privileged solution is to assign a data plane role, storage blob data reader at the container scope.
That's the answer. This ensures they can pull the logs, but they cannot access the ARM endpoint to change firewall settings, replication, or delete the storage account itself. Remember this functional gap. Reader is not blob reader. They are two distinct APIs and two distinct permission models that must be assigned separately.
Let's move to operational efficiency, scenario 4. Delegating VM restart. A support technician frequently needs to restart virtual machines to resolve issues, but must be strictly forbidden from modifying the VM configuration.
If the task is simple operational management, the wrong assumption is that we need contributor. Contributor is overkill, granting configuration and deletion rights.
So the correct, finely tuned role here is the virtual machine operator.
This is a perfect example of Azure's built-in role granularity. The VM operator role specifically grants the operational actions start, stop, restart, deallocate, without granting access to modify the machine size, attach disks, or delete the resource.
It's the definition of least privilege for a common support task.
It is. And the exam frequently uses these operator roles, like VM operator or SQL DB contributor, to test whether you know the hyperspecific roles that exist outside of owner and contributor.
Now let's talk about streamlining administration using scenario 13. Efficiency through customization. This is a scale problem. You have a team that needs 6 different built-in roles assigned to them, and they need this access across 12 specific resource groups. You're looking at 72 total assignments if you do this manually.
And that manual 72 assignment approach is a recipe for errors and technical debt. It's the wrong operational strategy. The efficient solution is to leverage the power of custom roles.
You essentially create a blueprint. You take the specific permissions from those 6 built-in roles and bundle them into one single custom role.
Exactly. You define that custom role once, and then you assign that single custom role at the necessary scope, assigning it once per resource group, reducing your administrative workload from 72 assignments down to 12.
And if all 12 RGs are under a common management group,
you can even reduce it to a single assignment. The key takeaway here is recognizing that any repetitive, complex role assignment process strongly implies the need for either a custom role or a consolidated assignment at a higher scope, like a management group.
This is where RBAC becomes conceptually inverted. Scenario 3. Deny access at all costs. We must ensure a specific high-risk user never gains access to a production resource group, even if they inherit the powerful owner status from the subscription level above.
The moment you need an absolute override that breaks the additive nature of RBAC, you must think, deny assignment. This is the security hammer. The wrong assumption is using a standard resource lock,
which only blocks modification or deletion, right?
Correct. It doesn't block the user from accessing it if their role allows.
So the deny assignment is conceptually correct because it overrides all the permissions, regardless of scope, role, or inheritance. But here is the critical complexity for the exam. We cannot simply click a button in the portal and create a deny assignment manually. Why is that?
Azure intentionally prevents human administrators from creating deny assignments directly. This is a depth security measure. Deny assignments are so powerful they can lock out global admins that they are considered a form of governance tooling that must be centrally managed and auditable.
So you can't have admins just clicking deny all over the place.
It would be impossible to troubleshoot access issues.
So if the exam asks how we achieve this guaranteed denial, what is the mandatory non-negotiable mechanism we must use?
We must use the centralized governance tool, Azure Policy. The correct solution is to assign a policy initiative with deny effect.
Okay, let's break that down for the listener. What is a policy initiative and how does the deny effect work?
An Azure policy is essentially a rule you apply to a scope. An initiative is a collection of related rules. When we apply a policy or initiative, one of its potential effects is deny.
Okay.
This policy effect instructs the Azure Resource Manager to monitor for the specific condition, like a high-risk user attempting to access a specific RG. When that condition is met, the policy automatically generates and enforces the necessary deny assignment object on your behalf. The deny assignment object is managed by Azure Policy, not by a human admin.
That is the essential insight. You are not creating the denial. You are creating the policy that causes Azure to create the denial. That separation is the key to passing this concept on the exam. The exam trap is crystal clear. If asked how to create a deny assignment, the answer is always through policy with deny effects.
We've established how humans authenticate and what they can touch. Now let's pivot to the non-human identities, the automation engines, scripts, and applications. This section addresses the authentication needs of systems, and the distinction between service principals and managed identities is absolutely mandatory knowledge for the AZ-104.
This boils down to a single question. Can the workload trust the Azure Fabric to handle its credentials, or must the workload manage its own credentials externally?
That's the perfect way to frame it.
Let's start with scenario 5. VM access to Key Vault. We have an application running on a VM that needs to retrieve secrets from a key vault. and the operations team has a strict requirement: zero secret maintenance overhead. They don't want to store, manage, or rotate a single credential manually.
That phrase, zero secret maintenance, is your definitive signal for managed identity. The wrong assumption is using a service principal here, which would involve generating a client secret or a certificate and placing that sensitive file directly on the VM.
Which creates exactly the management and security burden the team is trying to avoid.
Exactly.
So how does managed identity solve this? If the VM doesn't have a secret, how does it authenticate?
This is where the magic of the Azure control plane comes in. We use a system-assigned managed identity. When the VM needs to talk to Key Vault, it doesn't use a secret. Instead, it talks to a special local endpoint on the Azure Resource Manager service itself. ARM recognizes the VM's inherent identity, generates a temporary, short-lived security token specifically for Key Vault, and passes that token back to the VM.
So the VM gets a token, not a secret.
Yeah.
And that token is what it presents to the Key Vault.
Exactly. The Key Vault sees the token, verifies that the identity assigned to the token has the necessary RBAC permissions, which we granted to the managed identity, and releases the secret. Since the entire process relies on the trusted ARM fabric and the token expires quickly, no credentials are ever stored locally.
And the rotation is handled by Azure automatically. It's security and operational bliss.
It is.
And addressing the scalability point. If this workload needed to run across multiple VMs, like a cluster of web servers, which type of MI would we use?
In that multi-resource scenario, you need a user-assigned managed identity. This is a standalone identity resource that exists independently of the VM. You create it once, assign the necessary RBAC roles to it, and then attach it to as many Azure resources, VMs, app services, functions as necessary.
But the core zero secret benefit remains.
It does. The identity itself just becomes portable.
Now let's look at the counterpoint. Service principles. Scenario 12, external pipeline automation. We have a deployment pipeline, maybe Jenkins running in an on-prem data center or GitHub Actions, that needs to deploy infrastructure to Azure automatically.
Here, managed identity is entirely invalid. The wrong assumption is trying to force an MI to work. Why? Because managed identities only work inside Azure resources. The identity relies on that local ARM endpoint we just discussed, which doesn't exist outside the Azure perimeter.
Since this pipeline is originating externally, it needs a traditional mechanism to authenticate from the outside world.
That is the role of the service principal. We create a service principal, which is represented by an application registration in Entra ID, and grant it the necessary RBAC assignments. SPS authenticate externally using explicitly managed secrets, or preferably certificates.
So it requires credential management, rotation, and storage outside of Azure.
It does, but it's necessary for external systems to interact with the Azure APIs.
This distinction is paramount for the exam. Let's lock it down.
Okay. External system trying to access Azure requires credential management or service principal. Azure-based workload accessing other Azure services must avoid storing credentials managed identity. If you remember the location and the credential management requirement, you will get this right every time.
We've covered the technical guts of access control. Let's finish with the critical administrative topics that keep an organization auditable, resilient, and secure. We're focusing on governance for external users and managing high-privilege internal staff.
These scenarios test your understanding of Entra ID P2 features and the necessary emergency mechanisms that protect the entire tenant itself.
Let's discuss scenario 6. Contractor access. A human contractor from an outside company needs access to your subscription for a 2-month project.
The standard security violation here is creating a standard internal user account for them in your tenant that saddles your organization with managing their password, their MFA, and, crucially, revoking their access when they leave their home company.
So the correct enterprise standard solution is to leverage B2B, business-to-business capabilities. You invite them as a guest user via Entra ID, and then you apply an RBAC assignment to give them access to the necessary resources.
B2B is preferred because it maintains their home identity. When they log in, they use credentials managed by their organization. If they leave their company, their account is disabled at their home tenant, and access to your Azure environment is immediately terminated.
It's efficient, auditable, and shifts the lifecycle management burden away from your IT team.
Absolutely.
This brings us back to our identity distinction for the external world.
Yeah.
We said if the external entity were automation, it would be a service principal. Let's just reiterate that.
Yes. B2B equals external human identity. We use B2B because we want that identity to be managed by the home organization. Service principal equals external automation identity. We use SPs when we need a local identity to issue tokens and perform API calls from an external system.
Now, internal staff governance. Scenario 11. Restricting admin actions by time. Security dictates that admins should only possess elevated permissions when they are actively performing a task, similar to just-in-time access principles.
This is purely a governance challenge. The wrong assumption is that standard RBAC and MFA are sufficient. RBAC grants permanent access. If an admin's permanent contributor role is compromised outside of business hours, the damage can be done immediately.
The solution for temporary, audited, and time-based access control is to enable PM, or Privileged Identity Management.
PM is a premium Entra ID feature that provides a control layer over role assignments. It transforms role eligibility into activation. Instead of permanently having contributor, an admin is eligible for contributor.
So to use it, they have to request it.
They must actively request the role activation, justify the request, potentially get approval from a manager, and the role is only granted for a fixed short duration, say, 1 hour before it automatically expires.
PM brings auditability and the principle of zero standing access. Every privileged action is documented with a timestamp, justification, and auditor approval status.
Which means any exam scenario mentioning auditability, temporary elevation, approval workflows, or time-based access control points directly and exclusively to Peel.
Finally, let's talk about baseline security with Scenario 15. Enforcing MFA. Security mandates that all users require multi-factor authentication for cloud access.
While security defaults would enforce this universally, they are too rigid for most enterprises. The solution the exam prefers, because it represents the highest level of fine-grained control, is conditional access.
The correct solution is to configure a conditional access policy requiring MFA for all users. CA is the industry standard because it allows us to build complex rules.
Exactly. Requiring MFA only when accessing specific applications, or only when logging in from outside a trusted corporate network, or only when logging in from a non-compliant device.
CA gives you surgical precision.
It does. And it's critical to remember, as we discussed in the service principle section, that SPs cannot use MFA. They must be excluded from these CA policies and must rely on certificate-based authentication for external systems.
We saved the most important governance and resilience concept for last. Scenario 10. Break glass accounts. You need to establish emergency recovery accounts for tenant-wide emergencies.
Specifically for situations where conditional access policies break or the primary admin loses their MFA device and is locked out.
This tests administrative maturity. The wrong assumption is trusting normal admin accounts that are subject to all the CA policies you just enforced. If the CA policy breaks, those accounts are useless for recovery. The correct solution is mandatory for all Azure tenants. Create 2 cloud-only global administrator accounts. These accounts must be explicitly excluded from all MFA and conditional access policies. These are the break glass or emergency access accounts.
Why cloud only? To avoid reliance on federated systems like an on-prem identity server that might be offline or compromised. Why 2? For redundancy. They are intentionally stripped of your best security MFA to ensure 100% access.
Which means they must be secured physically.
They're highly complex passwords stored offline, potentially split between tamper-evident envelopes, and used only as a last resort.
This intentional bypass of security is the ultimate test of resilience planning. Any exam question mentioning emergency access, recovery, or fail-safe admin access is pointing you directly to these break glass global administrator accounts. You need to know that they are necessary and that they must be excluded from your conditional access rules to fulfill their purpose.
They are the paradox. The accounts with the highest potential security risk are the ones that ensure your tenant's ultimate resilience. Their existence confirms that you have planned for the worst-case scenario.
This has been a massive tour through the complexities of Azure identity and access. If you can internalize the core architectural decisions we discussed today, you are ready for the AZ-104 exam.
I think so. We've connected the dots on 4 critical high-level concepts.
First, the core divide. Entra manages the users and identities. RBAC manages the resources and configurations. Second, privilege versus scope. Contributor modifies resources but cannot assign permissions, and management groups are key for scale.
Third, plane separation. Management plane roles like reader are useless for accessing data plane content like blobs without dedicated data roles like storage blob data reader.
And fourth, workload identity. Managed identity stays inside the Azure trust boundary and avoids credentials, while service principals reach outside Azure and require managed credentials.
By understanding the functional differences. The why behind contributor being safer than owner, why deny assignments require policy, or why PIM is essential for temporary admin access, you transition from memorizing facts to thinking like a certified Azure administrator.
That conceptual clarity is what makes the difference between merely studying for the exam and truly preparing for a real-world career in Azure administration. Focus on these distinctions, and you'll recognize the traps instantly.
And finally, a provocative thought based on our discussion of emergency procedures. We established that break glass accounts must bypass your stringent conditional access policies to ensure recovery. That intentional security gap creates a massive target. If an attacker compromises one of those highly privileged accounts, what is your detection strategy? If the usual security layers are intentionally stripped away, you must rely on advanced telemetry. Your next deep dive should be exploring how Azure Log Analytics and Azure Sentinel are configured to specifically monitor all login attempts and activities associated with those break glass accounts, immediately alerting you to unusual spikes or geographic deviations in their usage. That proactive monitoring is the final layer of protection for your most sensitive identities.